Hello everyone, welcome back to our Algebra 1 course. And today we're going to be continuing on in our Algebra 1 course, talking about exponential functions. This is lesson 4.6, and that means that it is unit 4, page 6, if you're following along in the online module. And last lesson, we started to get into how to transform some exponential functions. And what we looked at was when we added a multiplier, we could, actually, let's go ahead and put this up. With the multiplier at the beginning, this A right here was our multiplier. And with that multiplier, we found that there were three things that we could do. If it was a negative, so if A was less than 0, you would see a reflection. Okay. If A was greater than 1, you would see a vertical stretching. Okay. And if A was, let's do it this way. If A was greater than 0, that's a 0, but less than 1, this is option 3, you'd have some vertical compression. So we have all these things, and you could actually have a combination of them, because this right here, if A is less than 0, really just means if it's negative, right? So if it's -1, it is simply a reflection. But if it's -1/2, you're going to combine this vertical compression with the reflection. Or if it's a -2, you're going to combine the vertical stretching along with the reflection. So that's what A was. And we went over that in our last lesson. If you notice, we've added 2 more changes, 2 more ways to modify our functions or equations here. And one thing that we see here is that what's happened directly to the x is we've subtracted a number. H just represents, it's going to tell us that it's a number. These are not going to be variables. These are going to be actual numbers, some real numbers input. So x minus h. Now this is considered an inside change because this would be done, we have some implied parentheses here. This would be done directly to the x before anything x is happening to anything else. And these other ones are considered outside changes because they happen at the last part after x has been doing its work, right? So h, if you notice, this is a subtract h, whereas the k is a plus k. What that means, if you have something like x minus 4 up here and a plus 4 here, this is a positive 4 instead of a negative 4 because the negative is there. Okay, but that also means that if then you have a plus 4, then the change is a -4 change, because because of this negative, we have to always take the opposite of what we see as our change. The positive means we can just take whatever is here. So if it's positive 4, we take a positive 4 change. And if it's -4, we take a -4 change. So whatever sign you see in front of the K goes along with that number for the change or the adjustment or the transformation. But with the H, it's always going to be the opposite of it. All right, so let's look at what these letters actually do. How does it transform our graph? How does it change our equation? Well, the H is going to shift the graph to the left or to the right. So if you have a positive 4 change, that means it's going to move, everything's going to move 4 places to the right. If you have a -4 change, that means everything is going to move 4 places to the left, because when we have our coordinate plane, our positive numbers are on this side and our negative numbers are on this side. It's just like a number line, right? So if we have a dot right here, say, and we have a -4 horizontal change, it's going to move 1, 2, 3, 4, and this would be your new point. That is a horizontal shift. Okay, so H is responsible for your horizontal shifts, and they always happen the opposite of whatever you see there. So if it's a negative, that means your change is a positive. If it's a positive number or a positive sign, a plus sign before the H, that means it's a negative change. All right, K, that's going to shift your graph vertically up or down. So A is the stretching or the compressing. So it's going to pull it or compress it. Whereas K is going to just move it directly up or directly down. So if this is your graph, it takes and moves the whole thing up. Whereas with the vertical compression and stretching, it would look more like that. So it still is in the same place down here. It's just being pulled up on one end. With the vertical movement, everything is going to move an equal amount. With this one, with the stretching or compressing, the movement or the change between the two grows as the number increases. You see that? And these are all even. So that's the difference between a vertical stretching or compressing versus a vertical shift. Okay. And I want us to look at some of these things and how they might work. So what I'm going to do, because I want to switch us over to Desmos, I want you to play around with Desmos and see what kind of things will change with Desmos. What kind of things change in your graph if you change some numbers around. So we have A times B to the X minus H plus K. So I'm going to write that there so we can see it. That's an A. So we can see it on our Desmos screen. All right, so let's switch over. Here's my Desmos. So to get here, all you have to do is type in Desmos, DESMOS.com/calculator. And I know this isn't a calculator. This is a graphing thing, but it is a graphing calculator. It's a type of, it's a way to graph functions. So what we wrote here is A times B to the power of X minus H plus K. So I want to go ahead. Remember, we cannot have 1 being raised to the power of X because that's not an exponential function. But what I'm going to do is go ahead and put 1 in for everything. 1, okay. And then I'm going to put times, instead of B being 1, because I can't have that, I'm just going to use 2. And then I'm going to put it to the power of X minus 1. Oh, it didn't keep me with the X minus, it's not doing it. Probably because I don't have it in parentheses. There we go. X minus, let's start with 0 so we don't shift it at all. All right, and then plus 0. All right, so we're not changing the X when we subtract 0. It's still X, right? Our 1 isn't changing anything, our multiplier, because a multiplier of a positive 1, everything's going to stay the same. And our plus 0 at the end, if whatever your number you have, if it's 500, you add 0, it doesn't change it at all. So right now, this is our standard equation of B, in this case is 2, raised to the power of X. So what you see graphed on the screen in front of you is the basic exponential graph of 2 to the X power, okay? This is 2 to the X power. You see it crosses the y-axis at the point 0, 1, and that's important for us to note. Okay, you see it has exponential growth, right? And it has an asymptote of what? Of 0, x, y equals 0 is our asymptote. Y equals 0. That's important to know. We'll get to that later. I'm going to rewrite this up here so it's out of my way, but you can still see it. All right. So let's create another one. We already know what's going to happen when we change the A function. Control C and Control V. Cut or copy and paste. We already know what's going to happen when we change A around. So if I change A to 10, look at how it really got pulled up. Well, what happens if I change it to 0.1? See how it got squished down. What happens if I change it to -1? It got reflected. What if I do -10? It got reflected and stretched. We're very familiar with A. That was our last lesson. So I'm going to leave A just how it was at 1 and not bother with it for now. I want to mess with my H and see what happens. Remember, H is our horizontal change. It's easy to remember H horizontal, H horizontal. So it's our horizontal shift. So it's going to take the entire graph. It's not going to stretch it. It's going to take everything, every single point, and move it to the right or move it to the left. Okay. So let's see what happens when I put in a +1 for where the H belongs. I put in a +1 and it's positive because there's a negative here. And remember, the change is the opposite. So you see everything moved over 1. So at this point, it's only a 0.5 because it moved over a complete number 1. So at the point of 1, we can see that's the vertical one and the horizontal one. This is a point of, let me write it down. This one here is a point of 0, 1, right? And so when we added 1 into our spot for H, a +1 horizontal shift, this point moved over exactly 1 spot to the right. So this is now 1, 1. Okay. Well, let's see what happens if we move it over 2 spots. Well, in order to move it over 2 spots, instead of having a 1 in there, we would have a 2. You see how this point right here moved over 2 spots. So this is the point 2, 1, because it's a horizontal 2 and a vertical 1. Okay, so this horizontal change is clearly changing the moving over. You see that here in this point as well. It's moving over exactly 1. You can see here as well. It's moving over exactly 1 point. Everything is moving over exactly 1 point. It's the exact same distance between every single piece that got moved over. Okay. No matter what 2 X values you're looking at, it moved the exact same amount. Okay. So between any of these X values on the red line and the blue line, they have the same amount of change in it. And that change is whatever this is, right? So we're going to look at one more. And this time we're going to input a negative value to where our H is. And what that means is, since it's subtracting H and I want to input a negative value, I'm going to have to add H. So I'm going to add 2. And you can see with this one, what I have here crossing the y-axis moved to the left, a negative movement 2 places. And then the same thing happened with this point. It moved to the left 1, 2 places. And here, moved to the left 1, 2 places. Oh, sorry, it should be right there for 1. And this one, 1, 2 places. And so you can see how this adjusted quite dramatically where we cross the y-axis. We started at 0, 1 and we're crossing the y-axis at 0, 4. So this is going to change it quite a bit because we're shifting the entire graph. All right, so that's the H value. Let's look at what the K does. I'm going to turn these off. So that's our basic equation of an exponential function with a base of 2, right? 2 to the power of x. So let's look at what happens when I change the k value to 1. I'm going to go back and change my h value back to 0 so that I don't see that change. Oh, look at that. It took everything and moved it up exactly 1 spot. So you can see here, it's always good to look at your y-axis on these. So here we have 0, the point 0.01 became the point 0.02. Here the point 1.2 became 1.3. And here the point 2.4, oops, I'm in drawing mode. Let me erase all this because it won't, when I adjust it, it's not going to keep my points, my drawings in the same spot. So you can see that everything gets moved up. And when you zoom out, you can see even the line does not look like it's going to ever go down to that 0, right? These two, the red line and the blue line, are always going to look like they're exactly one place apart. Why is that? Well, remember in what we have here on our red exponential function, as it's going to negative infinity, it's approaching 0. Remember, 0 is our asymptote. Our asymptote is y equals 0 on the red one. But with the blue one, when we shifted every single thing on that graph up 1, that means our asymptote shifted up 1 as well. So now we have an asymptote of y equals 1. So that means that this graph is approaching the y equals 1 line and will never, ever, ever touch it, cross it, but it just continuously gets closer and closer and closer to it without ever actually touching it. And as you can see, when we're moving upwards, it looks like they converge into one line here, right? As we move upwards, because they're continually getting closer and closer together. But as you zoom in, you can see, oh, they're not actually touching, okay? So even though from further away, it looks like they're the same line, as you zoom in, you can see the difference between the two. So again, these lines, as the curve is moving upwards, they get closer and closer and closer and closer, but they're not going to touch either. Okay. That does not make this red line an asymptote though, because the red line is a curve and not a straight line. So it's not able to be an asymptote. An asymptote is a straight line that a curve approaches. Okay, so the curve approaching another curve does not make another asymptote. It is simply a second curve, right? All right, so let's adjust this other one. Let's adjust it to a larger number. Instead of +1, let's do +5, and I need to remember to change that back to 0. Let's see, what do you think that would look like? Yeah, let's leave it about there. All right. Well, I just messed that one up. There we go. All right, let's turn on this line and see what it looks like. It looks like everything got shifted up 5 places, and that's exactly what happened. So the point 0 got shifted up 5 places. So on our original graph, we have here 0, 1. Now we have 0, 5, because 0, 6, because 1 plus 5 is 6. And then here we have 2, 4. And if you follow this up, it's going to be what's 4 plus 5? 5, 6, 7. So it should be right at the +5. 2 plus, that's 2, 2, 4, and 4 plus 5, 5 plus 4, excuse me, not 2 plus 4. So 4 plus 5, 5, 6, 7, 8, 9. It should be right at the 9 spot. So let's look at where our green graph is. Erase these dots I put on here. If we look at where the green graph is at the 2 location, where does it cross? It crosses right at 2, 9, just like we had anticipated. So you can see that everything just moves up. So the asymptote, every single point, everything is going to move up. Let's look at this one. Instead of doing a positive number, let's put it down 3. And let's remember to change our inside change, our horizontal change back to 0. We'll turn it on and then zoom out. So you can see how it moved everything down 3. If you're looking here at the point 0, 1, go down 3, and this is point 0, -2, right? Here you have, well, that's a decimal point where it crosses there. Let's see if we can zoom in and see some easier numbers to work with. Here's point 1. We have point 1 at 1, 2, right? So that means that our purple line is going to be 1 what? Well, the 1 will stay the same and the 2 will change to -3. Since this was 0.12, this should be 0.1 for the same one, and then it should be 2 and then -3. So 1, -1. All right, let's look and see what it is. 1, -1. It's hard to see because it's behind my writing, but it's 1, -1 right there. So you can easily see how to do all of this. Now, there's 2 ways to graph this. Any of these graphs with all these changes, right? You can graph these. One of the ways is going to be starting with your original equation. So say you had your original equation of y equals 2 to the power of x, this equation. And then say you had a horizontal change of 1. So then you would shift everything up 1. I said horizontal, I meant vertical. A vertical change, shift of 1. So you switch everything up 1. And then say you had a horizontal change of 1 as well, a horizontal shift. So let's see what that would look like. So that's going to look, we're going to take everything and move it over to the right one. Now, let's see what it would look like with a multiplier, our A change, our compression or stretching change. So let's change that. Instead of 1, let's do a -1. Let's make it a reflection. What do y'all think that's going to look like? Remember the last one we changed, the last one we looked at was the green one here. And so I'm going to look at that. There you go. It's an exact reflection of the green. But notice it didn't reflect over the x-axis. What did it reflect over? It reflected over the asymptote. Remember, the asymptote is this y equals 1 right here. And it reflected, it was a direct reflection over, here's where it looked like my graphs were a little different. There you go. Over the y equals 1 axis, from the green to the purple, it flipped over the y equals 1 line, the asymptote, okay? So those are different ways. You start with the original and then you make each of the adjustments that you need to make. You flip it, you stretch it, you shift it, you do all the things. The other way is to, if you had this equation, you would go ahead and create a chart with all of your numbers. You could just like we did before when we were creating charts, you'd have your X and your Y. Make sure you have, some negatives as well as some positives. So you could go -3, -2, -1, 0, 1, 2, 3. And then you would just need to plug it in and figure out what all your values are for Y and go ahead and graph it, graph all those points and connect the dots and indicate the end of behavior of the graph. So those are the 2 different ways you can graph these equations, but you do need to be aware of what with the equation, what everything is that's happening to this graph. All right, so that brings me to, we have a worksheet here for you that I want to go over with you. I want to do with you. I want to do it together. We're supposed to identify each transformation of the parent function f of x equals b to the power of x. We need to tell if the function is decay or growth, and we're supposed to identify each transformation. Okay, so let's look at this. G of x is, okay, well, I see that b is a whole number, so this is going to be a growth. Okay, and then what's happening to it? The only thing I have happening to it is a change in my h. I'm going to have to zoom in a little bit here. I can't tell if that's, my eyes aren't good enough to see if that's a plus or a minus. All right, so this is growth, and that's an x minus 2. That means we're going to have a shift to the right 2 places, because a positive 2, remember we're looking at the opposite of that, tells us that it's going to shift to the right 2 places. Okay, so let's look at this one. We have a fraction that's being raised to the power of x. That means that we have decay, right? And then we have our k value added. So a k value tells us that we're going to have a vertical shift. A vertical shift. And is this positive or negative? Well, k, we keep the sign in front of it, so it's a positive shift, which means it's going to be a vertical shift up 3. Here we have a whole number, so this is growth. We have negative in front of it, so there's reflection. And then we have a minus 6 at the end. So this tagged on at the end, the outside change is going to be a shift up or down. Well, because it's a negative, that means a vertical shift down, right? So a vertical downward shift. And how many places is it going down? It's going down 6 places. A vertical downward shift 6 places. Okay, here we have a fraction, so that's decay. Our b is a fraction. Remember, we have f of x is a times b to the x minus h plus k. That's what we're looking at, right? And so our b value, what's being raised to the exponent that has an x, is a fraction. And that's what tells us there's a decay. There's a negative right here. So that tells me there's a reflection. Then I have right here a horizontal shift. Now the horizontal shift is going to be the opposite sign. This is a negative sign. So I'm going to have a positive 5 shift. A positive horizontal shift means a shift to the right. And it's going to be the value of 5. Okay. Now I also have a vertical shift here with plus 4. So I'm going to have a vertical shift that's in the upward direction because it's a positive 4. That was a negative 6. All right, so here we have a whole number. So this is growth. So then we don't have a negative sign, so there's no reflection. Let's look at the horizontal movement. I have a horizontal shift to the right. Horizontal shift to the right of 7. Shift to the right 7. Positive 7 because this is a negative here. And then we have the vertical shift here indicated by plus 5. The vertical shift is going to be an upward movement of 5 here. Okay, which one is A and which one is B? Well, B is the thing that's being raised to the exponent. So this is the B and 3 is the A. So that tells me that I have growth because my B is a whole number and not a fraction. This is the first one that's going to have any kind of vertical stretching or compressing. Now, do you remember? Hopefully you do. A whole number is going to be, instead of a fraction, is going to be what? Is it going to be stretching or compressing? It's going to be stretching. So this is a vertical stretch, right? The 3 is going, multiplier is going to give us a vertical stretch. Now let's look at our horizontal shift. Our horizontal shift, we have a plus 1 here. That means our horizontal shift is a negative 1. So we're going to shift to the left Oops, that's supposed to be an arrow. A shift to the left, 1 spot. This was to the right. And then we have a +2 on the end. So we know that our vertical shift goes upwards. How many? 2 places. Okay. Write a function for each graph described below. So last time we were given the equation, we had to figure out what the transformations are. This time we have to figure out what the equation is based on their description. So our basic graph is going to be 2 to the power of x, and it says it's reflected. That means we're going to add a negative to it. And that's the only change. So instead of f of x, I'm just going to write y. Y is -2 to the power of x. All right, so here's our base graph. It's translated up or shifted up 5 units. That means I'm going to have a +5 at the end. So I'm going to have y equals 1/3 x plus 5. All right, the graph of f of x is 3 to the power of x. To the left, 2 units. Okay, well, to the right was a plus. To the left, well, no, because remember our horizontal shift, we have the opposite of. It happens up here in this. So we have to do the opposite. So if the left is negative, a negative change, that means I have to add in here +2. And down means I'm going to subtract 3 at the end. So let's look at what this is going to be. I have 3 to the power of x. Then my horizontal shift, I'm adding 2 because a horizontal shift is always the opposite. So the left is a plus. And then down is a change, an outside change here at the end, and it's going to be -3. All right, our original graph is 1/2 to the power of x translated down 2 units. This one's going to be pretty easy. All we have to do is subtract 2 at the end. My x is applied to the whole fraction there. All right, the graph of f of x is 4 to the power of x stretched horizontally by a factor of 3. We did not get into how to stretch it horizontally, so we're going to skip that one. All right, the graph of f of x is 2 to the power of x up 4 units and to the right 3. So I'm going to take the horizontal change first. Y is 2 to the power of x. The horizontal change happens inside. It's an inside change. And we know it's always an opposite change. So if it's right, +3, I'm going to subtract 3 here in my equation. Up 4 units means I'm going to plop a +4 right there at the end of my equation. So my equation is y is 2 to the power of x minus 3 plus 4. All right, and that's all we're going to get into today on this graph. I do have some practice problems here for you to do. So go ahead and press pause on the video, work these out yourself. It says tell how each equation has been translated from the original exponential function. So pause the video, write it down in your notebooks, and then unpause when you're ready to review. All right, so here, our base equation is 3 to the power of x. So we need to talk about all the changes that happened here. The first change that happened is this negative. So we know it was reflected, right? The second thing here is this number 2, which means we have a vertical stretching, okay? So we've done this one, we've done that too. Now we need to do this, our horizontal change. Our horizontal change is always the opposite. So our horizontal change is actually a -2. So it's a shift to which direction? To the left 2. Okay, this -1 is a shift down 2. Okay. So now here we go ahead and do this. This is again, our original equation is 3 to the power of x. All of these are, so I'm not going to say that every time. You should see that. We have no negative, so there's no reflection. We do have a 1/2. 1/2 we know is a vertical compression. Okay, then you have this +2. That's the same thing as this +2 up here. So that's going to be a shift to the left. Shift left 2. And then this -1 is a shift down, a vertical shift down 2. Okay. All right, let's look at this one. Here we have the 3x is our our original. We have this 2 here. There's no reflection because there's no negative. This is a vertical stretching. Okay, cross that out because we did that. This time it's a -2 up here in this horizontal spot. So remember, we're going to do the opposite of that. That means this is a +2 change, which means our shift, instead of being to the left, is going to be to the right, a right shift of 2 places. And then this +1 is going to be a shift upwards. It's a positive vertical shift, shift up 1. That's a number 1 right there. Okay, so here's our original. This negative tells me there's going to be a reflection. Okay, I took care of that. -1, I know that I'm going to shift, because it's a negative, I'm going to shift to the right, because really my change is a +1, right? So I'm going to shift to the right. How many? 1. And then this +2 right here is going to be a shift up 2 places. All right, I hope you got all of those correct, and I'll see you at the next lesson.